All right, let's get this done, please. So sample problem. Next up, please. Two 9-volt batteries are connected to a series in which the inductance is 1 over 4 Henry and the resistance 8 ohms. Determine the current I if the initial current is 0. So basically, in this question, if you look at it, you're seeing that they gave you inductance and resistance. So it's an RL circuit. Let's take down values, please. First things first, they give us two 9-volt battery. So E is equal to 9 volts plus 9 volts. That gives you what there? 18 volts. That's a total. So an 18 volts in total is 2 9 volts. Next up, they said inductance is 1 over 4 Henry. Inductance L 1 over 4 Henry, and resistance R is equal to what there? 8 ohms. You are asked to find, determine the current if initial current is 0. Okay. I think it would have been determine the, now usually they will say determine the current after 3 minutes. After, so if they didn't tell you time, what they're expecting there is just simply an expression for current. That's I. That's all. Normally they'll say determine the current after 2 hours. They'll give you a time. But it didn't tell you time. If you're not told time, now what that means is simply get an expression or an equation for what there? Current. So how do you solve this? Let's recall equation. L of what there? The I dt plus R of I is equal to what there? E. This value is 1 over 4 di dt plus R 8I is equal to E. It's it. What did you hear? Let's make this stand alone. So what do we do? Multiply by what there? 4. Multiply by 4. Multiply by 4. You have 4 into 1 over 4 okay, plus 1 over 4 di dt plus 8I is equal to 18. Okay. So please help me out. Please help me out, please. 4 times 1 over 4, what happens there? Cancels out. I have what there? Di dt plus 4 times 8. What do you have there? 32I plus, sorry, equal to 18 times 4. What do you have there? 72. You have this. Of course, from this stuff here, next is to take integrating factor. My integrating factor is equal to exponential of the integral of whatever thing is attached to I, which is what there? 32 with respect to what there? dt. Integrating factor is equal to exponential. If you integrate 32 dt, what do you have there? 32t. You have this. Okay? Multiply by integrating factor. Multiply by integrating factor. All right, what do you have there? This one here, exponential 32t, that's integrating factor, multiplying di dt plus 32I, it's equal to 72. You have this. Multiply through this and this, what do you have there? Exponential 32t di dt plus this and this, 32 exponential 32t times I. Of course, this and then this and then this plus, next up this one here, 72 exponential 32t. I have this. We always said this one here is simply a derivative d of the t into I, which is this variable, times integrating factor, this one here, exponential 32t. It's equal to 72 exponential 32t. You have this. Because obviously I have to move this man, the t, over here. So I have d of I dot exponential 32t. This is equal to 72 exponential 32t dot the t. Next up, integrating. So integrating through. Another day, wonderful pack of chalk, finished. All right. Integral of d I dot exponential 32t, it's equal to integral of 72 exponential 32t dt. Okay. From here, this cancels d. I have I dot exponential 32t. It's equal to, let me save my time here. We know how to solve this. First things first, move this one outside integral sign. To integrate exponential 32, we said the concept is simply differentiate 32t. It gives you what there? 32. And that becomes what there? A denominator. So this is simply repeat this exponential 32t divided by, if I differentiate 32t with respect to what I have here, t, it gives you 32. That 32 now becomes denominator. That's all. Plus c. So that's your shortcut. All right. I have I dot exponential 32t is equal to these two, 72 all over 32 exponential 32t plus c. Okay, I now have I dot exponential 32t, it's equal to, give me this in lowest step, 9 over 4. 9 over 4 exponential 32t plus c. To get this value here, we know what to do. I'll divide here by exponential 32t, divide here by exponential 32t, divide here by exponential 32t. This will cancel this. So I, it's equal to 9 over 4. This will cancel this. So it's gone. Plus c all over exponential 32t. Let me write this one here in, what's it called? Index form. In index form, we have that I is equal to 9 over 4 plus, take the c outside, becomes c. If I take c out of this, like this, if I take this out, I'm left with 1 over this. 1 all over exponential 32t in index form becomes what there? Exponential becomes negative 32t. That's eliminate the minus here to the 1 here. Take a minus there. So you have this. So this becomes the answer to the question. Oh, we're given conditions. Yes. You said the condition was what there? At what? I equal to 0. At what time? Initial. At initial, what's t? T is 0. So put this. So I is 0. You have 0 equal to 9/4 plus c exponential minus 32 times 0. Obviously, I'll have this as 0 being equal to 9/4 plus c. This is exponential minus 2 times 0 minus 32 times 0 is 0. So I'm having exponential 0. That gives you what there? 1. Exponential 0 gives you 1. 1 times c is c. Move this man over here. Minus 9/4 equal to c. So what do I have there? Let me call this asterisk. Substitute into asterisk. So substitute into asterisk. What do I have there? I have that I is equal to 9/4 plus c. What's c there? Minus 9/4 exponential minus 32t. I can factorize 9/4. So I is equal to 9/4 into, of course, 9/4 divided by 9/4. I'll have 1 minus, if I take out 9/4 here, I'm left with this thing here, which is exponential minus 32t. So basically, this becomes the answer to the question here. So this is the equation we asked to find. And that's how we solve this particular question. There are names for this thing anyways. I didn't get you. Yes, so. If you don't give it to you, you should know what to do. Now, look up please. In this question, what you have here, this one that has exponential, that's the minus 9/4 exponential minus 32t. This is called the transient term. Why this one is called the steady term? Why this is called a steady term? Steady term. It's called a steady term because the value is fixed. You can't change this. It will always be 9/4. Why this one is called a transient term? Because it will always change depending on the value of what there? T. If t is 0, this will have an answer. If t is 1, this will have a different answer. So it's always changing. So it's called what there? The transient, right? Transient term. Transient, transient term. So if they say, what is the steady current? The steady current there is what there? 9/4 amp. That's it. They'll ask you from the equation, what is the steady current? The steady current is the current from the what there? Steady term. What's the steady term? The term that is independent of what there? A variable. This will always be 9/4. So in essence, the steady current here, the steady rate current here is 9/4 ampere. That's the steady rate current. That's about this. So this is RL. Let's just do RC. I'll call it a day. We good?
Get more by joining our Differential Equations channel membership or visit www.joniemanual.com/courses and get the Differential Equations Made Easy course. Both links in video description. Get more by joining our Differential Equations channel membership or visit www.joniemanual.com/courses and get the Differential Equations Made Easy course. Both links in video description.